This lecture video is about chemical bonds and the different ways in which elements can actually join together or be attracted to each other in order to form molecules. We're going to start with ionic bonds. Ionic bonds are a give and take situation where one atom is going to give another atom its electrons. And because we are either losing or gaining electrons, one atom is going to become both atoms will become charged. One will become more negative because it's picking up a negative charged particle, and one will become more positive because it's giving up a negatively charged particle. And so ionic bonds are going to be when one atom gives or transfers or donates an electron to another atom. The one atom that donates the electron is going to become a cation. Remember, a cation is a positively charged element, right? Because it's getting rid of this electrical charge, this negative charge. And the one that picks up or receives the electrons will become an anion because it's going to become more negatively charged. And because opposites attract, this attraction will hold the two elements together. And you can see that right here. So this one becomes a cation, this one becomes a anion. Now, the number of electrons that can transfer will kind of depend on how many electrons are in that outer shell. Remember, we want the electron to be stable, so we want the shell to be either full or empty, that outer shell. And so depending on how many electrons there are in the outer shell will kind of determine how many it can give. Now, ionic compounds have some very distinct properties to them. So first of all, ionic compounds are always going to occur between a metal and a non-metal. So one of the activities that you're going to be doing today or this week is that you'll be looking at a periodic table and predicting whether an ionic bond forms or a covalent bond forms. And all you need to do is look at the different elements that are involved and see, well, is one a metal and one a non-metal? And if so, then typically an ionic bond is going to form. Ionic bonds are stronger than covalent bonds, which we'll talk about next. Ionic solids are crystalline structures, so they form kind of like a crystal lattice, and so it makes them very rigid, and it also makes them very brittle. They typically have high melting and boiling points. The solids of ionic bonds in the solid state are typically really poor conductors of electricity, and that's because they're so embedded in this crystal structure that those electrons can't move very well. Now, however, if you dissolve ionic compounds into water, then because those electrons are all spread out, these can actually conduct electricity. And you'll be doing an activity today this week looking at electrolytes, and you hear about those all the time and what those actually are. The second kind of bond is called a covalent bond, and this is a sharing situation. So instead of an element actually giving electrons to another element or another atom, they're actually going to share the electrons in order to make each of the atoms more stable to fill their outer shells, which again is what we want them to do. So covalent bonds form when two or more elements share the electrons. So you can see in this diagram here, the hydrogens and the oxygens are sharing these electrons in order to make them both the hydrogens and the oxygens stable. So it's kind of like holding hands a little bit. Now, even though they're sharing electrons, some atoms or some molecules have two elements that will share the electrons, but they won't do it evenly, meaning that in the case of water here, the oxygen kind of pulls the electron a little bit closer to it than the hydrogen. So they're still sharing, but they're just not sharing it evenly. And that gives the oxygen a very, very slight negative charge because that negative charge is just a little bit closer to it. And it gives the hydrogens just a slight positive charge. So not a strong charge like in the case of an ionic bond where they're actually giving a full electron or receiving a full electron, but this uneven sharing does cause a little bit of a charge. And these are called polar covalent bonds because they share them, but they share them unevenly. If we have a situation where the hydrogens and the oxygens or whichever elements you're using in a covalent bond share the electrons evenly, so like right in between each other, then that's called a nonpolar bond. So unlike in an ionic bond where opposites attract, kind of keep those elements together, these elements are pulled together because they're sharing. They're actually connected to each other with this shared electron. So water is a great example of a polar covalent bond. So here's a water molecule, H2O, right? It's got 2 hydrogens and 1 oxygen. And these electrons are shared unevenly with each other. So the oxygen pulls the electron a little bit closer to it, making the oxygen just slightly negatively charged, and the hydrogens just slightly positively charged, even though they're sharing the electrons. Now, this is really important in terms of water because hydrogen bonds then, which is another type of bond that is a weaker bond than either ionic or covalent bonds, but a very important bond in terms of giving water some of its unique characteristics, which we'll talk about in a different lecture video. But what happens is that, again, because opposites attract, right? So we got this slight positive charge here. This oxygen is going to be able, from this water molecule, will be able to connect to the hydrogens or bond with the hydrogens of another water molecule. Now, just like ionic bonds have very distinct properties to them, so do covalent bonds. So covalent bonds are going to occur between a nonmetal and a nonmetal. So again, if you're wondering what kind of bond is going to form, look at your periodic table, find the elements, see, is it a metal, is it a nonmetal? That's the first question you're always going to ask yourself to figure out whether or not something is going to join ionically or covalently. Typically, covalent compounds are going to have lower melting and boiling points than their ionic counterparts. They're usually liquids or gases at room temperature. Solids are softer than ionic solids. They are poor conductors of electricity, and they are usually insoluble in water. So that's kind of the difference between ionic and covalent bonds in terms of what's happening with the electrons, different properties that each of them have, and how you can predict whether or not 2 elements will form either an ionic or covalent bond. If you have any questions, please don't hesitate to ask.